Good morning, 11th standard. Today we start new chapter of chemistry, and that is chapter number 3, classification of elements and periodicity of properties. But as you can see here that this chapter is basically on on that why there is need to classify elements. Okay. uh, हम अगर आपका क्या कर रहे हैं, एलिमेंट्स को क्लासिफाई कर रहे हैं, तो ज़रूरत क्या थी, why there is need to study this chapter first of all. So as you can see that at present 100 elements, 114 elements are known, and from these 114 elements, recently discovered elements, these are man-made, and scientists are continuously trying to synthesize more elements. So in that case, uh, such a large number of elements, it is very difficult to study individually the chemistry of all these elements, क्योंकि ये तो अभी और synthesize हो रहे हैं, and as well as the study of their innumerable compounds. बहुत सारे compounds बनेंगे इन बहुत सारे elements के आपस के combination से, and because it becomes very difficult to categorize them and to study them. So to ease out this problem, first of all, the scientists searched a systematic way to organize their knowledge by classifying the elements. तो यहाँ पर इतने सारे elements को study करने के लिए क्या किया गया, उनको एक systematic way में organize करने के लिए उनको classify करना पड़ा. And that is not only for to classify, but it is also necessary to know the chemical facts about the elements. Only when we categorize them, then only it is possible that we can know about their properties, and as well as the predict the new ones properties also of these elements for further study. So the arranging of elements into different groups on the basis of what? On the basis of similarities in their properties is called classification of elements. Fine. And the earlier attempt also was done on this one field, that initially there were 30 elements were discovered, and these 30 elements were earlier that was categorized into two groups, that is of metals and non-metals. But the defect in this classification was that it had no place for metalloids. कहीं जगह ही नहीं थी metalloids की, which have the properties of both metals and non-metals. So that were discovered later. So in this one field, further researches going on. Further researches were going on, and the first classification was done by the Dobereiner, John Dobereiner, and he gave the law of triad. Okay? On this one field. You have already studied about this classification in your 10th standard also, on chapter number 5, that is classification of elements and periodicity of properties. बेटा यही चैप्टर आपने वहाँ भी पढ़ा हुआ है, so हम उसी को अभी initially we are just revising that topic only. So according to the Dobereiner law of triads, elements were placed in a group of 3 on the basis of their increasing atomic masses. ठीक है, ये देखिए increasing order of atomic masses. When the three elements were placed together, then these are known as the triads, and these are arranged in this way, as you can see here, that like lithium, sodium, potassium is arranged in increasing order of their atomic masses, and lithium atomic mass is or atomic weight is 7, sodium is 23, potassium is 39. Similarly, calcium, strontium, barium is another one triad whose atomic weight are 40, 88, 137, and chlorine, bromine, iodide are arranged in order of their increasing atomic masses. Their atomic masses are 35.5, 80, 127. So these are arranged in order of their increasing atomic masses, where the where it is to be said that their some of the first and last element present in a triad is approximately equal to the atomic mass of the middle one element. मैं दोबारा बोलती हूँ बेटा, that the average of the first and the last element atomic mass is equal to the atomic mass of the middle element. ठीक है, तो ये डोबरेनर ट्रायड का रूल था, but there was a limitation in डोबरेनर ट्रायड that this defect is basically could not be correctly arranged into triads. जो triads उस टाइम हमने अभी डिस्कस किए, that was not completely क्या explain those triads also, like lithium atomic mass is exactly accurately it was 6.9, potassium का होता है 39. When we are taking out the average of first and third element, it comes out near about 22.95, whereas the atomic mass of sodium is 23. ठीक है, similarly the atomic mass of calcium is 40.1, barium is 137.3, whose average comes out 88.7, and strontium atomic mass is how much? It is 87.6. Similarly, as you can see in the third triad also, the average atomic mass of chlorine and iodine comes out is 81.2, but the bromine atomic mass, as you can see, is accurately 79.9. So in this manner we can say that this law or this classification was not accurately followed, and due to which it becomes the limitation of Dobereiner. Okay. Next is about when this law was not properly followed, then there is the another one classification given by the Newland, and who gave it in the form of Newland law of octaves. So according to the Newland law of octave, when the elements were placed in increasing order of their atomic weights, and it was noted that every eighth element has similar properties to its first one element. ठीक है, so क्या कहा था न्यूलैंड ने, that the when the elements were arranged in order of their increasing atomic masses, then every eighth element property is the repetition of its first element, and this relationship was just compared with the musical notes, like every eighth note resembles the first one in octaves of music. As you can see, in musical note there are 8 notes, that is sa re ga ma pa dha ni, and sa is the 8th note, which is completely similar to its first one. So at till that time only there were 36 elements were known, and Newland law of octave seemed to be true only up to the calcium. As you can see here, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Then sodium is the 8th element, which repeat its property like what? Lithium. And again the potassium in this one row again comes below sodium, which is the repetition of in its properties similar to the sodium one. ठीक है बेटा? So similarly the properties of beryllium, magnesium and calcium are almost similar, but after this law was also not to be followed. So as you can see here beta, Dobereiner has given a 3 triads. या Dobereiner ने जो triad दिया, that was applicable only up to certain extent, only with these 3 triads. Whereas अगर हम बात करते हैं Newland octave की, so Newland octave के time पे these elements were known, but the applicability of we can say the rule that was only up to the calcium. As you can see here, that beryllium, magnesium, calcium, they are almost resemble similar properties. Lithium, sodium, potassium again resemble the similar property, but if we are talking about boron, aluminium and chromium, so none of these elements resemble to the same group or shows similar properties. ठीक है बच्चे? तो इनमें सिर्फ इन 2 ग्रुप्स में हमारा क्या हुआ? सेम प्रॉपर्टीज शोन हो. Now when we are talking about the limitations of Newland's law, so this law, as I have already told you, up to applicable only up to what? Up to calcium only. Then it contained, at that time there were 56 elements discovered, and according to the Newland, there are only 56 elements existed in nature, and no more elements would be discovered in future. ठीक है? और elements future में नहीं आएंगे. And third जो drawback थी इनकी, that was कि in order to fit elements into the table, Newland adjusted 2 elements in same slot, and also 2 कह सकते हैं similar elements they also put in the same slot, as well as 2 unlike element also under the same node. 2 elements ऐसे जिनकी की properties resemble करती हैं, वो भी एक ही नोट के अंदर रखे गए, और जो 2 अनलाइक एलिमेंट्स थे उनको भी एक ही नोट पे रख दिया गया. जैसे कि एग्जाम्पल कोबाल्ट और निकल, दे आर प्लेस्ड इन द same slot of fluorine, chlorine and bromine. So fluorine, chlorine, bromine have very different properties, whereas cobalt and nickel, that are showing the different one properties. Next beta, there was a Lothar-MEYER classification also, and his classification was based on the physical properties. He plotted basically the physical property, जैसे कि आपका atomic volume है, melting point and boiling point against atomic weight, and he obtained a periodically repeated pattern. न्यूलैंड की तरह नहीं, that he also observed a change in length. इन्होंने ग्राफ प्लॉट किया था and he observed a change in length of that repeating pattern. Then by 1868 he developed a table of the elements. इन्होंने क्या बनाया, एक टेबल बनाई which closely resembles the modern periodic table. But till the time Dmitri Mendeleev has published his work, and due to which the Lothar MEYER work was not published. Fine. And Dmitri Mendeleev का जो काम था, because that was published, और उनके काम को क्या कर दिया गया, that was to be considered as the basic development for modern periodic table. So this is all about the Dobereiner triad, Newland law of octave, Lothar MEYER classification, and now we are moving to today's assignment, that is, what is Dobereiner triad, write the limitations of Dobereiner triad, state Newland law of octave, and write the limitations of Newland law of octave. Fine, you people have to do it in your chemistry register. Then go through the topic from your NCERT book also, and we will come with the another one video for further topic of this chapter. Till that time,